In the second revision video for Unit 3, we're going to look at plastics. It's hard to exaggerate the importance of plastics in society today. Plastics have replaced many natural materials. So for example, we use plastic instead of glass, we use plastic instead of metal, we use plastic instead of wood, and we use plastic instead of paper even nowadays in money. Money today, new £5 notes are plastic. So what are plastics? Right. Plastics are known as polymers, and they're made by joining together small molecules called monomers. Now, paper clips are good examples of what I mean here. Right. This paper clip is like a monomer. So if we have billions of monomers and we join them all together, we create a long chain called the polymer. Long chain, of course, would have billions of paper clips or monomers joined together, not just half a dozen. So the monomer is a small unit, and if you join together billions of them, you form this huge big molecule called a polymer. And the process we are going to look at is called addition polymerization. So in the process of addition polymerization, alkenes are the monomers. Now, the alkenes are derived from crude oil, so ultimately all our plastics are made from crude oil, and it's worth bearing that in mind because as crude oil gets more scarce, not only are we running out of a source of fuel, but we're also running out of the raw material for making plastics. Anyway, let's look at making some polymers from these monomers. First thing we have to be able to name the polymer. It's a very simple, straightforward process. If the monomer is ethene, then to get the name of the polymer, all we do is put the word poly in front of the monomer. So it's polyethene. Whereas if the monomer is butene, it's polybutene. So naming the polymer is very straightforward. As is the reverse process, if we're told the polymer is polypropene, then we know the monomer must be propene. So what I want to look at now is the process of addition polymerization, in which propene is turned into polypropene. Okay, so here's 3 propene monomers, and usually in exams when you're asked to show this process, they ask you to show you 3 monomer units joining together. You know, in reality billions join together, but obviously you can't show all that. So normally we just show 3 units being joined together. Right, it's called addition polymerization because it relies on an addition reaction. So as in all addition reactions, we break the carbon-carbon double bond, reducing it just to a carbon-carbon single bond. So these just become single bonds, leaving free bond on each carbon, which allows the molecules to join together. So a better drawing of the polymer is this. So this polypropene. Note that as in everywhere in chemistry, carbon always has 4 bonds. So it's essential that in the polymer you have this, what we call a free bond at the end. And it just signifies that this is just a small section of a very large molecule and it extends in both directions. So make sure you remember those free bonds. Sometimes you're also asked to draw the repeating unit of the polymer. So you just draw the section which, when repeated over and over and over again, will give you an accurate representation of the polymer. So if we take those first 2 carbons, first 2 with hydrogens on them, second one with a hydrogen and a CH3, then that just keeps on repeating. CH2, CH3, CH2, CH3. So the repeating unit would be this. Okay. And again, it's got the free bond at the end to show it's just a small section of a bigger molecule. Let's look at another example, as one that looks slightly more complicated. Okay. Say we had to show 3 of these units being joined together. Now, the first and most important stage is to redraw that molecule, that monomer, in what I call the H formation, where the C double bond C is the central bar of the capital H. So we've got C double bond C. And then each carbon's got 2 things hanging off it. So the left hand carbon, which is this one, okay, so it's just this bit we've drawn so far. So this has got a hydrogen, and then the other thing hanging off it is this thing with 3 carbons and 7 hydrogens. So I'm just going to draw it as C3H7, and the right hand carbon has got an H and a CH3. So once you get it into that H formation, it's dead simple to draw the polymer. So let's draw 3 monomers. Make sure when you're drawing this that the bond points to the carbon, because the bond points to the carbon. Okay, so there's the monomers. If we join them together to form a polymer, so the backbone is going to have 6 carbons, free bond at the end, and then we just put in the H, C3H7, H, CH3. And then we just have to keep on repeating that. And there's the polymer that you would form from this monomer. So no matter how complicated the initial molecule looks, as long as you can redraw it in this H formation, it then becomes really simple. And just highlight the repeating unit. So there's the repeating unit. That's a unit that just repeats over and over again. And that's how you get from even quite complicated alkenes to the polymer that you produce. And that's all there is about plastics. So 3 things you should be able to do. You should be able to explain the terms monomer, polymer and addition polymerization. You should be able to name the polymer made from a given monomer and vice versa. And you should be able to determine the structure of the polymer and the repeating unit given the monomer, and indeed vice versa.